So, how to make sense of a hybrid vehicle in simple terms? Just an introduction. So, I came across this drawing in the manual here, guys, and I think this is as good as any place to start to try and get an appreciation for the overall workings of a hybrid vehicle, in this case, the Prius C. So, what we actually have on this drawing is obviously a hybrid vehicle takes an internal combustion engine, and generally speaking a motor generator is combined in a power splitter device of sorts in order to utilize the best characteristics of both, realizing the efficiencies from that process, right? So what do we actually have on this drawing? We have the transaxle assembly or power splitter device, which basically consists of a cluster of two planetary gears combined into the one assembly, and it affords us the electric or electronic CVT function. It's an ingenious device, wee bit difficult to wrap your head around initially, but we'll take it one step at a time. What I'll do in this segment is simply discuss one mode of operation, just the ready function, where you actually step into the car, power it up, and nothing more. So you're essentially sitting there with the vehicle powered up in park, and we'll see what transpires. We'll go through a scenario. So again, what do we have on the drawing? The power splitter device, the two planetary gear stacks, motor generator number 1 and 2. In general terms, guys, on the Prius C, motor generator number 1 is utilized for a traditional starter operation and alternator operation. So that is to say that we can start the vehicle utilizing MG1. We have no traditional starter. It's done utilizing the motor generator 1 function. And we have motor generator 2, which is, in general terms, again, affords us the traction effort. So it gives us electric drive operation, if you will. And we can combine the internal combustion engine, shown in green here, and motor generators 1 and 2 in different modes of operation, again, in order to realize maximum efficiencies. So you can see the planetary stack 1 and 2. We have a common ring gear here, guys. I've color-coded this drawing here to try and let you appreciate the drawing in a wee bit more detail. I realize it's fairly dark and difficult to see the details, but it's the best drawing I could get my hands on. So we have the ring gear here shown in yellow. The two planetary stacks here have a common ring gear. Keep in mind here, guys, that if this ring gear is turning, the wheels are turning. You may be able to realize in the drawing here, it shows us the ring gear going to the pinion for the final drive. This is actually the differential assembly going out to the two front wheels in the case of the Prius C. So the planetary stack consists of sun gear in the middle, I guess modeled on the solar system. A planet gear, 2 planet gears, well, it'll be a minimum of 2 planet gears, just shown in simplified form here. 2 planet gears or ring gear, pinion gears in some terminology, and an annulus gear or ring gear, again in some terminology. And I appreciate there's 2 of these guys. I'm really only going to focus on the right hand side of the drawing, because it's the part that actually deals with that one mode of operation that I'm talking about, just where you're sitting with the car actually ready. And if you sit in the car ready for long enough, once you power the vehicle up, initially, of course, the auxiliary battery, the 12-volt system, is checking to see that everything is copacetic, and so long as it is, all the interlocks and safeties are made. It allows the contactors to close and apply the high voltage battery to put that online, if you will. And that's essentially what's powering the vehicle, including the aux system, because there's a DC to DC converter in the converter assembly, which is essentially an inverter converting the high voltage DC to AC, because these are they're synchronous 3-phase motor generators, guys. So from the high voltage battery, obviously, in order to utilize the DC in a 3-phase arrangement, we're going to have to invert it, apply it to the motor generator in order to utilize the 3 phases. And the same going in the opposite direction as well, because it can be used as a motor or generator. When it's in the generator mode, the permanent magnet rotor induces current into the 3 phases. Obviously, that 3 phases would have to be rectified in order to be utilized by the high voltage battery, which is clearly DC. So just in the interest of a wee bit of context, guys, here is the converter with an inverter assembly, clearly the internal combustion engine, and obviously living between the two and underneath the inverter with converter assembly is the gearbox down here, right? So a wee bit obscured from our view, but this line here is actually the high voltage DC coming in from the traction battery, which lives under the seat, as does the auxiliary battery. I've showed you guys this before. So the inverter converter assembly will take that DC in, and if we're looking to drive the motor, for example, it would go through the inverter assembly, because the motor generators are three-phase synchronous permanent magnet drives. That would need to be converted to AC in order to drive the motor. So this is motor generator number 1 and number 2, both inputs to the motors and outputs from the motor generators back into the system in order to charge the battery. So this will always be DC, of course, high voltage DC, and on the line here will be high voltage AC. The transition between the two will be done inside the inverter converter assembly. There's also a DC to DC converter in here, guys, because the inside here is the line that comes from the aux battery. That's the 12-volt line here. We need, obviously, if the traction battery has a nominal voltage of 144 volts, clearly we need to transition that down to a usable level in order to charge the aux system. And the high voltage battery is supplying the aux system, all the 12-volt users, as the car actually sits there statically as well. Don't forget, guys, the air conditioning in this is also electric, as is the steering. So there's provision for that as well. There is a tap off on the side there. That's the high voltage line, which is applied to the motor compressor assembly of the AC. So, and this is actually, in this, as you can imagine, has some massive solid state switching going on, right? Again, more about that later, guys, but this will generate a lot of heat. And it actually has its own dedicated cooling system here. You can see one line in, or that might be out, and a line here going back to the reservoir. So that's actually the line in, I believe. That's probably coming from the water pump. Yeah, this line here down to the, again, an electric water pump. It's duty cycle controlled depending on how much cooling we actually require. Its cooling will circulate through the system, back through the converter, back to the reservoir. So yeah, a lot to take in. We get into the car, hit the power on button. There is no starter per se, but so we power the vehicle up, everything powers up. So if we sit there for long enough, obviously the high voltage battery will deplete. In the case of the Prius C, there's some conditions which, if we drop below 40% state of charge on the battery, for example, we need to have some facility to actually replenish that charge, right, in order to keep the battery within its window of health, which is sitting statically in park, basically is around between 40 on the low end and 45% state of charge on the high side. So what happens is the power management control module will actually see that the battery is depleting, and what it will do is call for the internal combustion engine to come into operation. Why? In order to drive motor generator number 1 in order to replenish the battery. So what happens is motor generator number 1 will initially go into the motor mode of operation, generating torque in order to drive, you can see here, through the pinion, through the pinions and sun gear. It will back drive the shaft here, as you can see, in order to rotate the engine. The engine will, obviously the power control module and the engine control module are talking via the CAN bus, I'm quite sure, and will enable the fuel and ignition. We'll get rotation from the motor generator number 1. Once the engine comes up and online, now we can actually back drive the system via the damper assembly here. This damper assembly, in case you're wondering what it is, guys, just imagine it to be like on a manual gearbox, the clutch and flywheel arrangement. There's torsional springs in the center, the hub of the clutch disc that's just utilized to take up the torsional shock. it essentially it's very similar in operation and design to that. No clutch per se, but a damper. Take out the rotational shock. And then the engine can actually backdrive motor generator number 1 through the sun gear and pinion arrangement. It will be rotating, and then you can utilize it in a generation mode in order to replenish the high voltage battery. Again, it would be done so that 3-phase power would be transmitted or transferred to the inverter assembly. Inverter with converter, it would be rectified and then stepped down in order to charge both the high voltage battery and indirectly the aux battery through a DC to DC converter. Obviously the battery is at 144 volts nominal. We're going to have to chop that DC up and essentially transform it down until probably 14 volts, 16 volts, something like that, in order to charge the auxiliary battery. So again, a lot going on here, guys, as I said, but this planetary arrangement is utilized to combine the efforts from the motor generator 1 and 2 and the engine. And I think that basic mode actually begins to show us on a functional level how this actually all operates. So let me show you some details from a scan tool that will maybe clarify this basic mode, park mode, let's call it, of operation, and how the motor generator number 1 in particular interfaces with the engine, the internal combustion engine, and how the two actually operate in unison in order to sit there and park and ensure that the high voltage battery stays at a reasonable state of charge. Okay, so what I'm trying to capture here, guys, is the torque that's actually being applied from motor generator number 1. If the motor generator number 1 is operating in the starter mode, i.e. it's about to bring the internal combustion engine into operation, of course it will rotate the crankshaft via the transaxle planetary gear cluster there. It will apply a positive torque in order to get the engine to actually rotate, and then once the engine is operating, we can then apply the torque the other direction, transition motor generator number 1 into a generator mode, and the torque should be applied in the opposite direction. So the line here I have graphed. I just have the state of charge of the battery here, guys. As this drops below just below 40, that's when the call for the internal combustion engine will be made in order to apply the drive, so we can replenish the charge in the battery. So I just have that on the PID, the data, and I'm graphing, as you can clearly see, the torque. So this is the positive direction and the negative direction. It's at the 0 line at the moment. So the engine should be starting here momentarily. If I've got my understanding correct. There it goes. You can clearly hear the engine is operating here, guys, and there you go. You can clearly see a positive torque applied, and then as it transitions into generator mode, the engine's up, and it takes this amount of time for the engine to come up to start, come up to speed, and then we transition in the generation mode. Now we'll actually go minus 14 Newton meters of torque. That's because we're driving the motor generator number 1 as a generator now, which that all makes sense. I hope it makes sense.